So this session, we're going to be focusing on cloud technologies and how people are using and embracing cloud technologies in their institutions for research. Also be looking at the challenges and, sort of any issues or future issues that may be coming apparent as we go forward. So my name's Emma Barnes. I'll be chairing the session. I lead the research and high performance computing team at the University of York. We're at the sort of earlier stages of using cloud for research. I'm sort of excited and would love to have more cloud. I think there's a lot of potential there, but I'm also frustrated with how to sort of give this to researchers, to academics, to be a useful tool. When I first sort of saw cloud, I thought, right, brilliant, I'm going to build a giant cluster in the cloud, it's going to be amazing. And then realism hit. And then you have to think about interconnects and storage and all that sort of stuff, and also the cost. So I've scaled back my approach going forward, but I do think there's a lot of potential, a lot of things we can do in the cloud. So if I can introduce the panel, and we can just go from the left-hand side of me.
Hi, James Hetherington, Director, UCL Advanced Research Computing Centre.
Hi, I'm Simon Hood. I'm Head of Research Platforms within Research IT, within IT Services at the University of Manchester.
And Martin Callaghan, Research Computing Consultant at the University of Leeds.
I'm Christopher Woods, Head of Research Software Engineering at the University of Bristol, and a disembodied head on the screen, I think.
Okay, so I think we'll sort of head to the second question on my form, just to confuse everyone. I suppose one of the big stoppers for us and blockers I found in the University of York is expertise and skill sets. Cloud is quite a different kettle of fish to what we're used to. We're coming from Linux and HPC backgrounds, and I found this quite challenging. There's also different variants. We've got Azure, we've got Google, and academics may have some particular credits for AWS, and they come to you very excited and they want to build something and they want to do something, but then you have to take a step back and say, well, we have to build this, and that will take time and it'll take some upskilling. So be curious to know what the rest of the panel have also experienced going forward with this sort of thing. Do you want to go first?
Let's go first. Okay, so I think for us at Leeds there have been probably three elements to that have helped us and supported us in upskilling and developing new skills. So firstly, like many of you here, research computing is part of IT services. And IT services at Leeds had a big push into adopting cloud and cloud technologies for all sorts of infrastructure a couple of years back. University made a decision to go for Azure as the one and only cloud, which is a decision, but that has come with it a lot of support from Microsoft. And one of the elements of that support, and I think it's actually been quite useful, is the Microsoft ESI, which is the Enterprise Skills Initiative, which is a really good online training program, which means you can get all of these Microsoft certifications as a user for free. Quite a lot of effort, and there has been a push to get everybody in IT services through a few of the fundamentals level courses as a starter. And that sort of helped to get people going. I mean, even in our team and more widely in the infrastructure teams, it's been a while since people have done exams and training courses. So that itself has been useful for people just to get them into this idea of studying and building skills. So that's very, very much sort of abstracted away from reality. So what we did on top of that is we'd run a bunch of peer training sessions where we went off and developed something interesting. And we had a sit down on a few afternoons and sort of taught each other and went through the practical implementation of these, which led us into taking these one step further and creating a series of tech talks, tutorials for our research community, which actually went down pretty well. And on the back of that, developed interest for said researchers to come back with, I've got this interesting problem. Do you think we can talk about it? We've never managed to get that implemented on HPC. That cloud thing you were talking about might have a little bit of relevance. And that's where we are now, with a few interesting little projects in development that are very much not HPC, that are using some of these interesting cloud-native technologies. But perhaps we'll talk a little bit more about those later on.
Thank you. Okay, so we've had, I guess, a pretty different experience at Manchester. We've clearly been a bit less organised in regard to training for Amazon or Azure or Google at Manchester. Within Research IT, we've been largely focusing on Amazon for the very simple reason that they've been incredibly helpful and obviously offered us lots and lots of free tech support and solutions architecture and so on. Our first project in Amazon, our first major project, was to look at bursting our high throughput Condor pool into the Amazon spot market. It's kind of a natural match, and it looked as though it would be cost effective. So we pretty much just dived in without any training and worked with the developers at University of Wisconsin in the States, and indeed some of the technical Amazon people. Just dived in, made it up as we went along, figured it out, and it worked beautifully. So we were all very confident at this point that, we can just do this cloud stuff, not a problem. And then our second major project, we were pushed into using the cloud for our second major project, building a so-called trustworthy research environment or data safe haven for hosting and processing sensitive data, biggest use case being NHS Digital's patient data. We were pushed into using cloud because of our cloud-first philosophy, strategy by our then IT director. So the decision was made, forced upon us. And it turned out that the Condor approach really was not going to work because if the Condor platform broke, well, it doesn't really matter. It's a transient platform. There's no sensitive data in it. What's the worst that can happen? Not a lot. The TRE is something completely different. It's got very sensitive data in it, and it has to be there 24/7, 365. We needed to take into account resilience, security again, more security, information governance, ethics, everything you can think of, data sharing agreements, the works. We struggled. We've managed to almost deliver it. We're nearly there now. We've done all the tech stuff. We've just got the information governance reviews to do and so on. What we have very much learned is if you're doing that kind of platform in the cloud, you really do need to learn an awful lot of stuff, which is very different from your traditional old-fashioned Linux HPC, which we know and love. It's been a learning experience.
So I think in order to answer this question, we need to decide on what we mean by cloud here. There's no such thing as the cloud. It's just a computer in somebody else's data center. What we actually mean by here is a few different things. The use of infrastructure as code, building your infrastructures against some kind of API layer, which we can do against both on-prem cloud and the commercial clouds. The commercial cloud business model, and it's is separate from that, and it's useful to think about those two things separately. So when we're talking about training engineers for cloud, what we're talking about is training engineers for building infrastructures on top of a stack layer of infrastructure as code, and that works whether you're doing OpenStack or OpenShift on-prem or whether you're working with any of the big cloud vendors. And that mind shift of training, and we're seeing more and more people, creating some kind of local on-prem cloud infrastructure and then building their HPC capabilities on top of that. So that training transition is a skills modernization right across the systems administrator community that's going on, I think. In terms of that training transition, I would argue that you want to look at what are the conceptual layers that are agnostic and transferable between the different cloud suppliers. The trainings that the cloud suppliers will give you are great, but they will they emphasize the dialect, right? The AWS dialect or the Azure dialect, because that's what they're commercially interested in teaching. You need to prepare yourself to get some training on how you do Kubernetes on AWS and use that to make it into a wider set of knowledge of knowing how to do container orchestration, across multiple platforms. And that piece, going from the particular bits of training that the cloud suppliers can offer you, which you should do because they're good and it's a nice packaged bit of training, and working out how to make that supplier agnostic. The other piece is I recommend building a cloud strategy around some of those standards-based layers. So think about Kubernetes, think about Docker, think about the various object store tools. If you've learned how to work with object stores rather than file system using S3, it's reasonably easy to translate it into using the AWS equivalent once you've got your brain around that, and there are other examples of that. So that's where I would argue on the training for our research infrastructure developer systems administrator community. There's another piece, though, that we need to do of training here, which is just as important as training our community, which is training the research communities. When you have research communities that are, we've spent a long time getting everybody through the idea of writing a shell job script for submission to an HPC cluster and teaching people how to frame their workloads in ways that work well in cloud. Is different. We need to go through a comprehensive program of getting research communities knowing how to write Docker files, right? I think that will make it much more likely that we can get a smooth transition into that future as well. So the training piece needs to cover both the research communities and the research IT community. Over.
Chris?
Yeah, I fully agree with James, and actually that kind of leads on to what I was going to say. So at Bristol, we're kind of slightly different in that a lot of our cloud work has come because the various cloud vendors just kept approaching us and giving all of our researchers free cloud credits. And this meant that we had to work with all of most of the cloud vendors, so your Oracle, Amazon, Google, Microsoft. And what happened was that the researchers came to us as the research software engineering group because we were viewing cloud as software-defined infrastructure. Mm-hmm. And so it's not so much I'm going to build a cloud infrastructure and then let the researchers use it. It's how do we build a piece of software that happens to spin up hardware as part of how the software runs. Yeah. And so when you flip your mind over to the fact that actually it's a software engineering challenge as opposed to the software engineering challenge where the hardware becomes part of the software, you see that it's a very different mindset to what you're producing, computing environments. How are we building these very different things that don't replace our HPC, but give new capability? So because we viewed it as software, we ended up investing in the layers where the software did abstract away the differences between clouds. So we worked at the Terraform layer, and obviously the combination of Terraform and Ansible works really well, and at the Kubernetes layer. And what we ended up doing was basically building that knowledge within the research software engineering team, because, while the researchers ended up so I have a slight disagreement with James. I think the researchers do need to understand a bit of how they're working with cloud, but actually I think most researchers really don't care. And actually the researchers we ended up working with were the ones who are using your R Studios and your Jupyter Notebooks and going onto Google Colab or wanting to run this big job. And actually what we found in the research software engineering team is just to build them a platform that let them work in that way themselves and really try and not expose them to the cloudiness underneath if they didn't really want to use it. So it has been really this growth of skills within the research software engineering team that's culminated around our cluster in the cloud project, which sort of then abstracted all of the different clouds so that we could then spin up on-demand Slurm clusters very easily across any infrastructure.
So I don't know if anyone in the audience has any opinions on this in terms of skills and cloud technologies. Anyone online? Okay, so I think one thing I'm quite interested in is sort of this abstraction and how far do you go. I'm sort of interested in what people have currently done to try and kind of hide this cloud layer. And, there is, we try to do that in kind of our HPC systems anyway, whether it's through Jupyter Notebooks or Open On Demand or something like that. What are people doing to do that for cloud technologies as well?
Okay, so I think there are actually two groups of researchers. So there are some researchers, as Chris mentioned then, who really want to have it all hidden from them and want a much easier route to consuming cloud services, because frankly all I want to do is my research. And if this facilitates or helps me do it faster, better, quicker, cheaper, then I'm all for it. But we've also got, and I'm sure many of you have colleagues like this as well, who themselves are interested in the cloud technologies, and they do not want it hidden from them. And for us at Leeds, they have been the sort of first and primary group of researchers who've come to us with these problems. They've asked some very specific questions about containerization and Kubernetes, and how do I access these technologies? And they've come to us both with the questions and the answers. So I think my word of caution here is that we've got to be able to support both of those groups of people. Certainly it leads the people that perhaps wanted this hidden from them to be able to consume the cloud service were those people who needed access to a trusted research environment. Now, we had one of these at Leeds some years ago, on-premise architecture, and it worked, but it was of a fixed size, a fixed capacity, and more projects overloading virtual machines, and it rapidly became too difficult to manage. So we've had an operational trusted research environment in Azure for about 16 months now. And it works, and it's fantastic, and all of the complexities hidden from people. But the number of people it took, at one point there were 40 people working on the project. It took a good 2 years. It was nearly a year late. And I'll echo some of Simon's comments there, is that it's an incredibly difficult, complex, and at times quite frightening project to get involved in. Not the technology, all the other stuff that you mentioned. It's terrifying. All the governance is frankly terrifying. So we're right next to an NHS trust. They have always wanted to partner with us on those projects, and you've got to get this right. So again, like I say, from my perspective, it's these two groups of people that we can create a solution that helps them solve research problems that sort of just happens to use cloud. And then there are that group of researchers, the more computationally focused ones perhaps, that really want to use the technology and that want access to these DevOps skills themselves. They come along to our training, they come along to our tech talks, and they're as much challenging and driving us in adoption of these tools and techniques as we are ourselves. There you go.
Okay, at Manchester, we've traditionally dealt with the engineers and physical scientists, and then maybe 5 or 10 years ago, the life medical health scientists came along. But our biggest growth market, if I can put it that way at the moment, are the people from humanities and the other people that traditionally, you show them, your nice, wonderful Linux command line on your wonderful HPC cluster, and they look at you. They start to shake and the sweat appears on their forehead and they run away screaming. Nevertheless, these people that we look at strangely, because we love Linux, they're doing valid research and we have to help them. So something that's really starting to take off at Manchester is use of cloud to provide interactive computational resources. And the two tools that we've had some success with, Service Workbench in Amazon that we're looking at the moment and developing, and something we've had a great deal of success with is Jupyter, which I'm sure many of you have used. One of my team has implemented a Jupyter tool platform in Amazon, which has got scalable using Kubernetes in the background, so it happily scales from a few students to 400 in a few minutes. Which is perfect for the teaching and learning community, which kind of, I guess, brings me to another aspect of it. Because the researchers know and love us in research IT, or most of them tell us they do, they're coming to us with their teaching and learning issues, because they go to enterprise IT and they say, yeah, we can deliver that for you in 2 years, because that's the way they do it. They come to us and I say, Daniel, this guy wants Jupyter, but for 400 people. And he goes away and thinks about it. Next day says, does this work? 24 hours, which is the great thing about research IT people. They just do stuff. and the great thing about cloud, as opposed to the terrible thing about cloud, which Martin and I mentioned. It's all this complex, horrible stuff which scares the hell out of you.
It does.
But for interactive compute, both for research and teaching and learning, which hides all the nasty command line stuff from everybody, cloud is really, really good. Be it on-site or Amazon, Google, Azure, whichever.
I think in York that's where we're heading, more for the interactive approach, probably with Azure, but it's certainly these users who prefer a Windows environment, and we don't, they just want a bit more RAM, a few more cores, nothing major. So actually, for a few hours a day or a couple of days a week, that cloud would be perfect for them. And we've got the infrastructure being built around it anyway, so we can piggyback off that.
So I think these things are best off not conceived as a cloud transition, but a couple of other different transitions. So we've talked about infrastructure as code, software-defined infrastructure as one of the key transitions that often goes under the name of cloud. Another one that's happening here is what communities have been talking about as science gateways or research gateways for 10, 15 years. So the idea that instead of expecting all of our scientific computing workflows to fit within the job script into Grid Engine or Slurm or whatever, that you have a web-based interface to analytics, upload a data set, etc. And people have been doing that on top of traditional HPC, and now we're starting to see these solution layers for particular research disciplines which integrate research data management, computing, and access to algorithms and scientific software into a solution layer which sits on top of compute and data infrastructure stack. And that's emerging as a key part of the solution structure. So and when we publish an application, right, we talked about users who are looking for a Windows desktop. What they're usually really looking for is a particular application, right? And a way to manage the data to access that. I prefer finding ways to nudge users to manage their data well in a good curatorial practice, rather than a giant bucket of data in an enterprise Windows home drive. What are the ways in which we can nudge that? And using the Science Gateways model gives you some affordances to help to nudge some of those good data management practices in research. So to conclude, if we create these frameworks for researchers, thinking them as a solution layer on top of infrastructures, it's not too important from that point of view whether or not it happens to be abstracted through an HPC cluster or abstracted through a Kubernetes layer, or whether it's in my data center or somebody else's. It's the solution layer that matters. Over.
Chris?
Yes, I think, again, I'm continuing on from James very well. I see cloud very much as the stepping stone to, a late 2020s, 2030s, when we're much more in a software as infrastructure or software as a service kind of world, where effectively I need to go and do some big data analytics on a data set. I just go to the big data analytics application. I need to go and run a batch computing job for some MD. I just go and spin up my batch computing software, and off that goes and runs that particular application. And we're seeing this transition where we're moving away from batch HPC being the only type of sort of advanced computing we're doing, to now actually having lots of different types of compute and data analytics, data like heavy compute going in as well. So the other thing I'm hearing sometimes is people talk about these researchers that just want to use Windows or don't want to go to our scary command lines. But the question asked is, why should they? These are people who are doing amazing work in our studio or on Jupyter notebooks. And what they suddenly need to do is burst out from their notebook because they need to do a big machine learning training job, or they're doing interactive sort of data visualization. They've loaded up like 10 terabytes of data. They're sorting it through. They want to do a filter and then a mean and then a bit of processing. And that on their laptop would take an hour, but they want to do it in 5 minutes because they're doing this as part of this interactive exploration of data. What we're seeing is this movement towards this need to have on-demand interactive access to large amounts of compute, and not have it as this thing that you submit a job to a queue and eventually get a result coming back later. And it's this movement towards where we're consuming compute as this burstable thing that's part of an application layer, which I think is the main transition we're going to see over the next 5 to 10 years. The other thing I want to say about cloud is in the Amazon's, Oracle's, Azure's, and Google's, is the benefit of them is it's enabled us to do hugely rapid prototyping.
Yes.
So we're able to just pick up and assemble these sort of like lovely big computing infrastructures and spin them up in a prototyping way in 5 minutes, play with them, see if they suit our needs, and then tear them down if we don't need to. So it means this iteration cycle of us actually trying to design new infrastructures to meet these different research needs is now significantly quicker than it used to be before, because we don't need to buy the stuff now. And I think what we're seeing in these, the first panelist sort of mention of the split of the researchers who don't care about infrastructure and the researchers who really do care about infrastructure, is the researchers who really do care about infrastructure are the ones who are looking to build the services of the future. So they're the ones who see that what we have now doesn't actually work, and they're these sort of this building toolbox of tools that they can assemble into something that will work for them from the future. And that's why I found cloud reminds me of my time as a PhD student, which was at the dawn of the Beowulf era, where effectively we were told you had to use these big like silicon graphics machines, but actually in our PhD groups we were all like, well, I can go and buy some stuff from Argos and like from PC World and just put them onto like shelves, and we'll write our own schedulers and we'll write our own bits and pieces, because we can play with this new toolbox of tools that Linux has provided to build our own Beowulf clusters. And I feel that cloud is basically the same thing. It's providing these very tech savvy researchers a new toolbox of tools to play with, so that they can build the things that people will be using as mainstream services in 5 to 10 years' time. And so I agree with the comment that we somehow need in our institutions to enable us to run cloud or run these new services as professional services in a good way, where the researchers don't have to care about the underlying infrastructure, but equally provide a mechanism by which the researchers who are building the infrastructures of tomorrow are able to just have a sandpit where they can just pull any cloud vendor's stuff together and throw it together in ways that could be fun and interesting.
Can I follow up on Chris? There's another interesting point to this, which is that the economics of whether you buy this capability from Google, Microsoft, Amazon, etc., or do it with your own in your own data centers, is an entirely separate question from all of this area we were discussing about the next generation of infrastructures. And if you get that abstraction layer through those APIs, that becomes those become orthogonal problems. Chris hit on something really interesting, which is the power of deletion of your prototypes. Once you have that separation layer, whether you're doing it on commercial cloud or with an agnostic infrastructure investment on-prem, it doesn't just change. It changes the way you do project management and think about projects inside the institution. When for each service we're creating, there's a big procurement, right? You naturally fall into Prince-type methodologies because you are making irrevocable decisions. There's a reason people don't use agile methodologies to build buildings, because if you put the bricks in 2 feet to the right, it's quite hard to unbuild the building and rebuild it the other way. So it's only because software is changeable and therefore change that agile methodologies work well in software. So if we want to move to a lighter touch planning process, it's because our mistakes are easily revocable. The goal of being able to tear down the entirety of your research IT infrastructure every Tuesday and rebuild it and nobody noticed is where we need to get to in order to realize that.
So if I could just come in quickly with that, that's okay. Completely, James. And this is where with cluster in the cloud, I mean, when we originally thought about trying to give cloud to researchers to run HPC, it was like, okay, let's build a big shared HPC cluster they can all use. But with cluster in the cloud, it's actually you build a researcher their own personal cluster, and then you tear it down when they've finished. And suddenly what you've got is this thing that spins up for the experiment. they run the jobs on it for the experiment, and then they tear it down and delete it at the end. And that changes the way you think about the cluster, because now your shared disk doesn't have to cope with 1,000 users. Your shared disk just has to cope with the needs of that one experiment. The software that's installed in the cluster doesn't have to be everything and worrying about modules and everything else. You now just install the software that's used for that one experiment. The user accounting, again, is just for the users who are part of that group. And the researchers themselves, when they suddenly realize it's their own cluster they can do anything with, they can do things like run interactive jobs on the head node, like run a Jupyter Notebook instance to do data analysis after the batch computing is complete, which you could never do on a shared instance. And it just changes the mindset into sort of how you're using it. So shared becomes not sharing one big physical infrastructure. Sharing becomes sharing the budget of which you're spending and allocating to the cloud.
Thanks. I think we have some questions.
Yeah, just to bring in what's happening in the chat at the moment. So there's some support for lowering the barriers, which Chris brought up. And then there's a question from James saying, I'd love to hear about anyone's experience with usage of Terraform and anyone who has ported between cloud vendors with it.
So I think I can answer that one. So we use Terraform as the backend for cluster in the cloud, and it's brilliant. So I think Terraform is something which people should be learning in a sort of research software engineering team, because it enables you to really think of infrastructure as code. In terms of porting between cloud vendors, the Terraform, what we did is, rather than the cloud metaphors for Amazon, Microsoft, Oracle, Google, they are so different that you can't really write a single Terraform script that works beautifully with all of them. So instead, what you have is you kind of have your generic script at the top, and then you move into cloud vendor specific subscripts, which are running the bits at the bottom. So you're kind of doing like 2 layers of abstraction within the Terraform script. So using the Terraform metaphors for the individual clouds in your cloud, in your cloud specific part, and then you sort of have your own kind of metaphor that's just above that you're working on the more general script part. But it does work beautifully well, and now we have it in place. It's the thing which other members of the group then learn, and I think learning through the Terraform layer how clouds work actually gives you a better overview of what cloud can do than maybe starting with the Azure docs or the AWS docs, etc.
We have a question.
So Chris made an interesting comment about changing what's meant by sharing from sharing the hardware to sharing the budget. And I was wondering if he or any of the rest of the panel would like to comment on how you manage that, because then you're devolving to research groups or users within the research groups how you fairly allocate the overall budget for using the resource. Any comments on that would be very interesting.
Yeah, that's a really interesting question, because we've 2 models really at Leeds. So we have the traditional shared infrastructure HPC model that is a stakeholder model between the faculties, and that is continuing. Our cloud projects at the moment have been research grant funded completely, and to be quite brutal, it's been, if you've got the money, you can do whatever you please. Up to and including the amount of money you have. And almost everybody's been quite happy with that position. So we're not yet in that position, which I think you were getting towards, was how do we take that stakeholder HPC model and work out how to turn that into a more sort of cloud-friendly one. I don't know the answer to that one. I think that will be a very politically difficult move to make in many of our institutions. So if anyone in the audience has done it and has an answer, I think the rest of us would be very pleased to know. Have you done it at Manchester? No.
We did it at the Turing badly.
What went badly?
So we had $1 million a year budget of Azure Cloud Credit.
Yep.
And it was our job to track that through dashboards, and when it was looking like we were not going to use it all up, encourage the researchers to do more with it, to allocate budgets to different groups as they came forward through an allocation process with the committee, and as we got towards the end of the accounting period within which we were doing that $1 million, worry about going over. The annual event that was the NeurIPS conference, when everybody at the Turing wanted to go hell for leather training models as fast as they could, didn't fit well with when the accounting period end of year was, such that, if that had been towards the beginning of the accounting period, we could say, everybody knock yourself out on your conference prep, and then we'll use the dregs over the rest of the year. Didn't work out like that. That's what I mean by badly, and there was a few difficult year ends. The getting good tooling on what people are actually spending, and your visibility in your dashboards, and having processes to check in and picking up the phone if somebody's burning faster than they expect. And they won't be sympathetic if they're just near the end of a really important piece of work, and you haven't warned them. Oh, you do know you're about 2 days away from running out of your budget, and then they only find out about it when the thing stops working. That's not ending happily for you in research IT either, even if it's their fault.
Yeah, I think it's about visibility. So, as I said, most of the cloud projects we do have been based on, there's been an allocation of cloud credits. So it's a fixed amount of money to spend within a fixed amount of time, allocated to a research group or several groups. With those groups, they see the budget up front. And then what we do to get them used to things is when we create a cluster in the cloud for them, we can say how large the cluster can be in maximum, although it could be in theory infinitely maximum, and it's something we can change during its lifetime. We start them off with only allowing them to spin up a small number of compute nodes at a time, so they can begin to, and we get them used to the idea of profiling their job and beginning to plan how much this particular scientific experiment is going to cost. And so they run that and they see their initial costs, and then we can increase the size of the cluster to whatever they need it to be. And then they see the alerting. So you get your predicted spend, you get your actual spend. We set the alert levels, and they see the emails. So they know, okay, this experiment cost me £5,000. This one cost me £10,000. And that enables them to plan. What I like about this is it brings it back to this environmental issue, where at the moment we've trained researchers that the way you get the most work done is by throwing as many jobs at the queue, and we share a resource by how long is somebody willing to wait and how many jobs they're willing to throw at the queue, and they don't think about the actual environmental impact of their research. By bringing it back to money, and they go, actually, this experiment's going to be 3,000, that's going to be 5,000, this is going to be 10,000. They plan the experiment in more detail, they put more effort into optimizing the job and reducing the number of things they're going to run, so that it gets the most out of it, into reusing it, and it brings the resource consumption into their focus. And because this is visible through the entire thing, they know what they're doing, and they can't blame us. We provide the infrastructure, they have the budget, they can see their spend. It's up to them to optimize it, just like a biochemist optimizes their spend on assay kits, and a roboticist who's doing loads of things would optimize the robotics run to make sure it doesn't burn through their budget. I think this question of consumption is again another trend which is going to hit us before 2030, in that I don't think it's even justifiable for us to not have researchers think about how much they're consuming when they submit a job. And so I think we need to move towards a world where even if they're not really paying money, they understand they're paying in carbon, and almost begin having caps on usage. So that, a particular research this experiment should only be producing like 10 kilograms of carbon, and you have that budget to work from. In terms of where this has kind of worked, obviously the way that the national infrastructure works is it is basically a payment model. You're given your killer allocation hours, your cows, and researchers know how to budget within their cows. And it's really just at the university level, we've kind of not done that, at least not at Bristol. I know many other institutions, we just give them who can stay as long in the queue as they want. And I think that is something which would have to change. The other side, in terms of moving forwards, what would I like to see in terms of cloud, in terms of payment, is almost, at the moment, we give researchers an amount of money for compute, which is basically the HPC budget. And we tell them you have to spend that on the batch HPC, and you must then submit jobs to the queue, and your usage will be how long you're willing to wait in the queue. And that works for the researchers who've got a lot of jobs to run, but it doesn't work for the researchers who have maybe one big job they want to run at an urgent time in the year. So it's not fair to them. I'd rather we had institutions say, well, this is the amount we're willing to spend on HPC. we'll spend some of it on batch HPC, but then we'll give an allowance to other researchers to spend on interactive computing and data computing. And if they want to spend it on cloud in an on-demand way, then we'll find ways of supporting that.
I think that's really interesting, Chris, because currently in York, the Central University Fund the HPC facility, and my concern is a little bit about the early stage researchers as well, and ensuring that, you know, they may not have any grants coming in yet. They need time to develop, they need time to you know, build up their case to start putting in these grants. And my concern with cloud is, are we going to lose that? Are we going to prevent them from having access to that? So I do like the idea of, you know, giving people an allowance of some kind to allow them to choose which method will suit them best, and it still helps these sort of early stage or experimental choices that people want to try going forward.
And there are in some institutions a move towards, I won't say withdrawing support, but investigating whether support should go to unfunded research. And I think that's quite a dangerous step to take, because it's not unfunded, it's perhaps self-funded. But I think, as Sarah Harris mentioned on Monday afternoon, is that all research starts somewhere, and they start with pet projects. They start with that unfunded research, where you develop a proof of concept, you develop a case that eventually becomes a funding proposal that fails a couple of times, and eventually something gets awarded. So I think we just need to be very careful about how we address that innovation and research pipeline and make sure that it is funded and supported. And I think one point I'll make on a couple of other points is that those early careers researchers make mistakes. They are suboptimal very often in the way that they develop and run their jobs and pipelines. So our job as research computing professionals is to help them become more optimal. But again, expecting people to be experts at the start of their career, I think, is something we need to be very careful about.
We need to allow people to
we
make
need to
mistakes.
we need to allow. Yeah, it's the job of a PhD student and a postdoc to make mistakes, right? And we need to continue to support that, and for them to make interesting mistakes that challenge us.
Provided they don't bankrupt the university.
Provided they don't bankrupt
Which is where cloud comes in.
Which exactly. We yeah.
Brilliant. Does anyone in the audience have any?
Just right back here. Something I dropped in the chat, but is that the question is for on-premises sort of cloud. Oftentimes you talk about interactive jobs, various things, but people aren't awake 24/7. And oftentimes with these highly flexible systems, you put down a decent chunk of money to buy lots of cores, some other, components. Are there any suggested methods on, okay, 50% of your nice on-prem cloud system is currently running idle? What do you do with that? So.
Yeah, I can answer that question directly if you don't mind me jumping in straight away. So I wanted to draw everybody's attention to a tool called Prominence. It was developed by European Open Science Cloud. It's a platform that allows users to exploit idle cloud resources by running their workflows in a sort of a batch style system, and it features sort of hierarchical bursting. So you start with like private and then academic and then public clouds, and yeah, so if you've got researchers that are happy writing a Docker file, then it could be something worth looking at and pointing them towards as a tool to let them exploit cloud resources, again, in a free way using public clouds and things like that as well. So just want to make sure everybody's aware of that, because it touches on a lot of the points that have come up today.
The other thing is this is the same problem that the commercial cloud vendors are addressing when they have their spot instance models. And one of the things that's emerging on that is it's a really good idea to have some RSCs make sure that your codes can do checkpoint restart. Everybody make sure your codes can do checkpoint restart. It's really important, because then you can use spot instances, and spot instances are cheap, and you can catch the "I'm about to throw you off" signal and save your work. There's going to be a lot of work on checkpoint restart for codes over the next few years, in my opinion. Over.
Brilliant.
Mary, was there another?
Yeah, so if all of this has been answered, so there are a couple of questions in the chat at the moment. I just scrolling up. So one that actually related to something that was mentioned earlier. One thing that was challenging at the Turing was when we switched from sponsorship, a Microsoft donation, to pay for what you use, either via pre-commitment or pay-as-you-go model, is managing budgets. For example, setting hard limits on accounts, such as budgets or expiry dates. We had to develop our own budget management system in order to make sure that our users do not spend more than they are supposed to. I'm interested to hear if others had a similar experience with managing public cloud budgets and the tools they used for it.
Yeah, we're having this struggle at York as well. It's not my team, it's the infrastructure team working on. I've got the AWS side, which is actually pretty decent in terms of, but you know, a lot of that was done in-house to try and alert people of their spend. The Azure side still needs work, which is sort of delaying us kind of pushing it forwards to academics, because we want to make sure they can actually budget and spend what they want to spend and not go over. I have worked with, so our Viking clusters actually, we have a service provider, and I've done a project with them, and they've sort of cloud bursting, and they've been looking at sort of creating a costing tool with that, and that's actually quite good. So we may find, you know, it comes from these sort of third-party vendors as well, but it's something I constantly raise with the cloud vendors, because it's also if you're wanting to cost a grant as well. You know, we get people coming to me and say, I want to use the cloud, how much will this cost? And there's, well, what do you want to do, and how are you going to do it, and how long are you going to do it? And you can't just play with this. It's hard to play with this and get the numbers right.
I can give one simple practical answer about tooling. When we first started using Amazon, our route to market was through a particular reseller who, not very helpful. Thankfully, our procurement office allowed us a different route to market through G-Cloud, and we currently buy our Amazon resources through a reseller called Software One, and they have some tooling called PyraCloud. I think I'm right in saying it works with both Amazon and Azure, and we found that to be really good at budgeting, forecasting, and putting limits on accounts as well, so that when a researcher blows their budget, they get killed stone dead, which is obviously very important.
Just to emphasise that point, there are some really good value-added services from these resellers. There's another company we've worked with for AWS called Strategic Blue, who offer similar services. They are well worth engaging with to help you understand how to estimate and how to budget. You know, your point there, Emma, it's quite frightening. You know, a researcher approaches you about a project, you can make numbers up, and they're going to be fairy tales, and it's really, really hard. And we need to somehow get much better at knowing how to estimate and knowing how to budget for these types of cloud projects where we are consuming by the clock. It's a very, very different world to the traditional HPC world that we've worked in. And you know, your point there, Simon, that PhD student who blows £2.5 million over a weekend because nobody was watching the control panel, the thought of that terrifies us all, doesn't it?
Absolutely. I can certainly recommend PyraCloud. I'm sure there are many other.
Yeah.
But yeah, engage with the resellers. They do have their value.
Yeah.
So I'd come in a bit with this, and so I'm not terrified because the researcher can't spend lots of money, and I think this is one of the things I'm continually talking to the cloud vendors about is the fact that the way that they set up their tenancy subscriptions, whatever they call it in their metaphor, is wrong. They do basically pay after use. But when they give you cloud credits, that's basically pay before use. You get a fixed budget. You know, the money's already there in the account. And once it hits zero, they terminate everything. And that's the model they should be using to sell to universities, or at least sell to researchers. And indeed, you can persuade the cloud companies, if you talk to them in the right way, they'll actually flip your account over to be pay before use, where effectively you transfer the money, it goes into a budget which you see, and when it hits zero, it gets turned off. The other thing which I think helps is if you're able to compartmentalize the budget, or even indeed have multiple subscriptions. So rather than trying to have one university subscription, we're all trying to manage 10,000 researchers in that, actually have per research group subscriptions or per research group budgets, so that then that research group has £10,000 and they're managing it. And they can't spend £1 million because once they get down to the bottom of, once they've spent the 10,000, that's it. Now, what we need to do is actually, in terms of the estimation, is provide that free institutional money to enable people to do the exploration in cloud, because you can't make it up. You do have to run the small scale analysis and the profiling, just as you'd be profiling on HPC before you then decide if you're going to run your massive job, and or profiling on your local cluster before you make the application to run on Archer. And so having the space to do the small scale profiling so you can then work out what it will cost to scale up is really, really important. And that's where I think the free money that comes from universities will be important. It's where effectively I think the free money that's coming from the cloud companies now is being used.
That point on separate master payer accounts, separate primary subscriptions, is the subject of a current fight in UCL. For good reasons, the sort of standard recommendation is a single master payer account for the university. The challenge for that for us, for the in terms of providing services to research communities, is I would like my team of research infrastructure developers to, you know, have the full access that they need to the systems in order to respond in an agile way and not be sending ticket requests to central IT in order to do things. But the delegated access control management and control tower on AWS doesn't seem to be there to enable that to work well. So the next offer was, okay, we'll give your research infrastructure engineers full root administrator access on the enterprise control tower. And I don't want that, because I don't want my team to be able to break payroll. So, so just to let the community know, and maybe people have got some tips, find me afterwards, to how to navigate this particular conundrum.
Yeah, I mean, it's a massive challenge. And I think this is where the cloud vendors are really missing a trick. So AWS Control Tower goes part of the way to the solution, but I don't think it solves it properly. I think we need to really question how many researchers really need access to the cloud interface. So my experience with research groups is they say, I want to use the cloud interface, but actually they really don't, and they don't understand it. They've ended up using the Kubernetes interface or the cluster in the cloud interface or another thing that's bounded.
But I do want the full access to that interface for my research infrastructure engineers within advanced research computing. That's the different question than, and I would argue, for departmental research technology. You know, we want to get to hub and, so in UCL we want to get to hub and spoke model, where we've got central advanced research computing, which I directed, but also a set of professionals of research infrastructure engineers, research software developers, data stewards around the departments and faculties. And the chemistry lead ResOps person probably also should have that kind of access. And then you've got, you know, a few dozen people with root access on control tower across the university, and you're screwed. So
yeah, this is what I'm saying. Control tower doesn't fully solve the problem. It's the thing which is holding cloud back, I think, from widespread adoption in universities, is them recognizing they're not working with one business. A university is a collection of small businesses that happen to share resource. And it's how they can build a subscription model which recognizes that collection of independent small businesses who all have a kind of centralized thing that they're working with, and essentially need for governance. That's the challenge.
Well said.
And just to emphasise Chris's point, that we're working with a model that isn't really designed for universities structured in the way that we are. So we're perhaps a little bit more fortunate than UCL in that research computing does have its own Azure subscription within the university tenancy. But that comes with particular challenges because our infrastructure teams understanding and IG implementation and rules around use of cloud are constantly evolving, that we find out after we've transgressed. And that is a challenge. Our School of Computing also has their own subscription that they use for teaching. So a few modules use cloud technologies where each student has their own resource group within the subscription. Now that has worked reasonably well. It's been our first year doing it this year. But nonetheless, students do daft things because, again, it's their job to do daft things. And again, this is where universities and research and teaching and the cloud vendors need to work together to help build a better model that we're able to consume, and bill and warn for these resources in a much better way than we're doing at the moment. It's a bit of a fudge, I think, at the moment, and with several fudges depending on the vendor and depending on the institution. But I'm not convinced that any of it is yet quite right.
Do you have any questions in the audience?
Yep. Here are two questions from Matt, and I'll read them both out, and then you can decide which one to answer first. The first one is, how do you identify what work would be well placed on cloud and what would be well placed on traditional HPC? What style of job, if any, would still be better suited to traditional HPC regardless of the accessibility of cloud? The second question is, how can on-premise cloud ever compete with one of the big providers? On-premise would inherently be of finite size and lacks the scalability that off-premise cloud can provide. It would also presumably be less cost-effective due to lack of economies of scale. So, two questions.
So to answer the second question, which I think is easier, there are a lot of there's quite a premium price for the higher end nodes, and whenever people do standard benchmarking of scientific computing workloads, we're not yet seeing for advanced HPC workloads any kind of cost advantage for commercial cloud at all. And that's, I think that wave is moving. Chris has a nice graph of how the wave is moving, but it's not yet crossed, and we're still hearing multiples of 4 or 5 for those kind of workloads. However, coming to the first question, which kinds of workloads are better off using traditional HPC and which ones are better off using cloud? I would answer that in terms of which ones are better off using distributed memory parallelism on a strong interconnect cluster, and which things are high throughput computing workloads, which are then probably better off done through a cloud type metaphor. My opinion is that there's a theorem that says unless you are doing work which, because there isn't enough memory in one node, needs distributed memory parallelism, you will not get time to science faster by working through a queue. Right? You can actually prove this mathematically, right? Your expected time to science of using one node running for a month, or waiting 29 days in the queue and having the job run in one day over multiple nodes, your expected time to science will be identical, and that's provable, unless one of the following things is true. Either the job will not run in a single node because you need distributed memory parallelism in order to make it go at all, or the systems are not reliable enough that you can actually run for a month without the thing crashing. And those are the two, as far as I understand it, provable reasons why you should use proper HPC. They are fantastic reasons, and you should use proper HPC. But unless you meet those criteria, don't sit in the queue. That's my view.
I mean, if I can come in to answer, I think, again, following James, cloud is not it's just a technology. It's like, again, I don't like the way that the cloud is described in these questions. For me, when do you need the job completed by? Are you doing something interactive? Do you need to complete it by tomorrow? And if the queue is full, then cloud is obviously better. It's kind of like, how long do you have to wait? That's the question I'd be asking. But in terms of James's point about single node, sort of being, if it can fit in a single node, why would you go and sit in a queue? One of the things I do with the cloud subscriptions at Bristol is we have researchers who need to just run a quick job, and I can just quickly spin up a 64, 128 core node now with terabytes of RAM, and they're suddenly running a Jupyter notebook on it, or they're running an RStudio session on it. And that is way more valuable to them than what we'd call a traditional HPC job, where they may have tried to munge that workflow to fit within a traditional batch HPC system. So I don't see cloud as being this replacement for traditional HPC. It's a new type of technology that really enables your interactive kind of jobs, which is currently not really, there isn't a home for that currently within universities. In terms of how could on-premise cloud ever compete with one of the big providers, what I think will eventually end up happening is you'll see a lot of the prototyping and the interesting sort of dynamic stuff happening on cloud, because it's way cheaper to use a 128 core node for an hour than it is for me to go and buy a 128 core node.
Yeah.
And so you'll see this thing where people just need these things for just one experiment. They'll just go in cloud and they'll buy it. And there's no way you can compete by providing that locally. But what you'll see is across an institution, you'll see the average kind of compute that's being used in the institution. And then, of course, it'll be much cheaper for you to buy that average and run it locally than paying the premium of having it running in a cloud center. And in that way, you could almost view public cloud as being your pathfinder, showing you the kinds of hardware that your institution is using. And then what you do is they're designing the cluster for you. So instead of asking what kind of processors do you want, what number of GPUs, what memory do you need, use what you're seeing them use on public cloud, see that it's costing you an arm and a leg, and then buy that locally and save the money. And suddenly you've now got an argument for why you have traditional on-premise HPC. It's buying the average from the cloud to save you that premium. And so you've got a reason to continue.
Yeah, that's a really good point.
So I'll give you another thought on that what type of job question. I'm personal experience here. So from my perspective, it's those types of jobs that can easily be decomposed into a number of steps. You know, a traditional pipeline or workflow that we might see in bioinformatics and genomics. And for those of you who that's your field, you'll know that you use a variety of tools, each with wildly different, very often, computational requirements. And we've used HPC clusters to run these pipelines and workflows for a while, and they're not a particularly good fit because we overuse one bit of resource and underuse it somewhere else. Whereas with these pipeline tools like Nextflow and some of the platform as a service genomics platforms that the cloud providers now provide as an easier interface to that cloud resource, we're not running HPC jobs anymore. We're running a script that runs a pipeline that magically creates and destroys cloud resources in the background when it's required. So we're hiding that complexity away from researchers and allowing the computational solution to look much more like the science. And perhaps this is a direction that we could go in. And there's certainly been our successes at Leeds, is by keeping the computational solution as close to the scientific problem and outcome as we possibly can, and abstracting away the cloud and computational complexity in the background.
There was one thing that I meant to say earlier that I forgot. It's just popped back into my head. There was a false assumption in one of the questions that the cloud is infinite. It's not. At the beginning of COVID, we ran out of cloud. That people should be aware of this. At the beginning of COVID, we ran out of cloud. And the big vendors have a list of which things they pull the plug on, and national security critical things stay up longest.
Yeah, I would agree with that. So we found that's actually a regular thing now, even during post-COVID times, that they ran out of cloud. Yeah. The one thing I also forgot to mention was the other type of workload that works well on cloud is ones where it's shared between institutions. So what cloud enables, which is very difficult to do within institutions, is for research projects which span institutions to occur. So effectively have the data stored with a third party and the compute running with a third party and paid for with a third party, then enables, say, five university research groups to then work in one space, as opposed to trying to navigate how we're going to get 4 other universities' researchers through our firewalls onto our local HPC. And we saw this during a COVID project where effectively we're having groups needing to share between the UK and the US. And it was so much easier to spin up a cloud disk and put cloud compute against that than it was to actually try and navigate getting through each of the institution's firewalls.
Yes, I just wanted to tell a little story which illustrates the difference between on-site and cloud, which actually relates to the Condor bursting that we set up a couple of years ago, 3 years ago. We've got a chemistry group on campus at Manchester who had spent the best part of a year doing a load of computations on a local compute platform. And 2 weeks before a conference, they discovered they'd made a mistake and it was all wrong. So they pretty much phoned me up and said, can we borrow the whole cluster to do it all again in 2 weeks? Obviously, the response to that was, no, However, it so happened that the type of work they were doing could be broken up into lots of relatively small bits, small in terms of time and in terms of computation. So we got this new widget. We can burst our condor pool into the Amazon spot market. We estimate it'll cost you several $1,000s to do it. If you can find the money, off you go, knock yourself out. They had the money. They did the whole lot in 6 days. They did exhaust the spot market in East Coast USA, but they got the job done.
Okay, my question was in regards of the proper use of HPC resources, because the speaker says that you might not use well and you can exceed it. So it took me several simulations to understand how can I distribute the cores or the things. And I am working in this like quite years, and I don't know, other chemistries or biology or other specialists can know that if there is somewhere I can understand, or how could you measure the complexity of how many resources I want to demand for doing simulations. If there a place that you documented that, because now I am working only with one multiphysics framework. I'm familiarizing with this, but if I stop that project and I will start with GrowMax or other applications, how do I know? I mean, I'm working now with I'm having my calculations in depends of the degrees of freedom, but I don't know about the other applications. You have experience of that or documentation about it?
So, first thing I would say is it's okay to get this wrong. One of the things that those of us who are enthusiastic in explaining and sharing best practice, and we love explaining and sharing best practice, can do by mistake is create environments that are hostile to failing forward. We see another example of where we see this is in open science practices, where open science is unfortunately getting a bit of a reputation for being a way of telling science communities off rather than helping science communities progress. So we need to caveat all of this with it's okay not to use the cluster as efficiently as possible, and if you want to have some MATLAB that is running really slowly and a few characters of improvement, you could get a 10x speed up. Sure, we should look at that and help, but we should never be trying to shout at people or get cross if they're wasting the cluster with inefficient interpreted codes. However, that said, I do think that a really important best practice is going through some test jobs to work out at what breadth of job your particular problem performs best. Make the graphs of time to science versus breadth, and work out what the sweet spot is. Auto-tuning methodologies are starting to make some of that easier, but it is a good idea to go through that exercise, I think.
I mean, I'd always say reach out to your local HPC or research computing team, because even if they don't document this in their own resources, there will be people within the team who have this. It's in our heads, isn't it? That we've been doing this for so long. You sort of know how applications scale for different types of applications. We might not always write it down, but please do talk to us, because we can have a conversation with you, as James said there, about helping you understand how your application works. But the more we talk together, the more the HPC and research computing team learns about those new applications and can support you better. So I would always say, please always reach out to your local HPC and research computing team, because they will be able to help you.
Okay, we've got 5 minutes left. Yep.
What's the panel's view on novel technologies in the cloud, like creating new processors or GPUs, and is there a role for the cloud in testing these things out?
Can I go first?
Oh, yeah, go on, Chris.
It's brilliant. It means you don't have to buy it. That's the ultimate thing. We play now with new ARM processors, with other weird processors. We're lucky to get some early access to things that are coming up and to feedback. And the reality is there's so much innovation now happening in the cloud because, to be honest, the private cloud companies, they're just throwing spaghetti at wall to see what sticks. So they're just trying everything. They're taking the financial risk of like investing in this stuff and then seeing who's going to buy it. Is there a market for it? And so it's a brilliant time for us in research where effectively, if you now want the latest ARM process or whatever, you can have it for pennies rather than having to try and get it bought and delivered and you've sunk some cost into it.
Yeah, I agree.
And perhaps there's an extension of that as well, Chris, in that there are, as many of us have spotted, quite a few smaller companies now with very interesting novel processor technologies. And some of them might not survive. So there's a chance that we may end up buying the latest amazing thing, and in a year's time they've gone bust, or actually more likely been bought out by one of the cloud providers. So it does reduce the risk, and as Chris has said, reduces the risk whilst allowing us to see whether that particular technology fits. Although I think there is a panel on novel technologies at some point, either today or tomorrow. So it's the next one, is it? There we go. So that's a good lead into that one.
Is there any more questions?
Yeah, I have a question or an observation. Are we, as a community, missing a trick? I'm hearing that the cloud or the use of cloud and the way you use it is offering some features and facilities which are useful to universities or users, which the assumption is that aren't available on conventional HPC facilities. But quite a lot of them are. There's nothing to stop you doing interactive computing on an HPC cluster. There are priorities, there are turnaround profiles that you can tune. You can do usage capping, you can do allocations. A lot of universities don't do that on their conventional HPCs. But if this is something that the community wants or the university wants, then question to the panel, should we be putting resources into implementing those on our local HPC clusters as well as the cloud?
One of the hedges we're doing against that challenge, and I think you're absolutely right, is we're buying consistent hardware between the stuff we're putting cloud-like APIs over and the stuff we're putting Slurm over. So it's easy to move resource between those capabilities. And indeed, if you can get abstraction layers, your scheduler type access modality and your Kubernetes type access modality, just peer access modalities to a common underlying on-prem hardware.
I think you're right, Simon. I think there are words of caution to be had here. You know, that one of the prompt questions we've got there is fitting into the enterprise IT model that is very much pushing not only for cloud first but cloud only, and that's probably not right for us either. And I think we're both very conservative, perhaps in HPC, but also absolute leaders way out in front. And I think we've got to try and be both. And continue to be both, whilst keeping all of our political stakeholders happy in universities as well, which is a very, I think you've intimated towards that, it's a very complex scenario to manage, isn't it? But we somehow need to continue to do that.
Okay, we've got 1 minute. Yeah.
Yeah, I just wanted to add something I think's been missing, at least for life science users that I primarily deal with, which is the data sets. So it can be as flexible as it likes on the cloud, but if they can't integrate their sequencing data with their electronic health records, it's no use. So that is a consideration. It goes back to the TRE question, really. And can you have a TRE that hosts the data sets you want and has the bursting capability? But I think that is an important part of this question of where the workloads go. Maybe more so for some fields than others. If it's simulation, you don't really care. But
there's probably a whole nother session we should have on the research data CDN, as I think about it. But that's yeah, you're right. But
yeah, I think you're right. But I think also that's the future, where effectively we move from just having data sets stored somewhere like a PDB to actually you're subscribing to a data set with compute capability, and we begin moving more towards moving software as a service applications onto national databases. so that then you're not having to move the data back to your local institution or to the cloud you're working with. And this is why I think that universities that say we're an Amazon only place or an Azure only place will be missing a trick, because actually there'll need to be a way of working with whatever is the cloud that's being used by the data provider.
Okay, so we're at the end of the session. I want to say thanks to the panel. Thanks to the audience as well.